Welcome friends to our channel. Chemistry is awesome. In chemical thermodynamics topic, in last video we saw the process and types of processes. We saw in that process and types of processes the meaning of process and types of processes. Process is nothing but the transition of one equilibrium state to another. Means conversion. Transition means conversion of one equilibrium state to another equilibrium state. So that is called as process. And in that process, we saw there are types. 4 types of processes we saw. What is the first process? That is isothermal process. Second, adiabatic process. Third, isobaric process. And fourth, isochoric process. In all these 4 processes we saw in previous video, so that is isothermal means what actually? Isothermal process means it is the process in which temperature of the system remains constant. Temperature of the system remains constant means T is equal to constant. So therefore change in temperature delta T is equal to 0. And here internal energy also remains constant, and therefore change in internal energy delta E also equal to 0. What about adiabatic process? It is the process in which heat is neither allowed to enter nor allowed to leave the system to the surrounding. Means here Q is equal to 0. Means exchange of heat from system to the surrounding, so that Q is equal to 0. What about isobaric process? In this process, pressure of the system remain constant. And therefore change in pressure delta P is equal to 0. So that is called as isobaric process. What about isochoric process? In isochoric process, it is the process in which volume of the system remain constant. Means here volume V it is constant. So therefore change in volume delta V is equal to 0. So all these 4 types of processes we saw in previous video, and these 4 types of processes can be conducted reversibly or irreversibly. So how it can be conducted, we will see in reversible and irreversible process. First of all, we will see the reversible process and its features. What is reversible process? In the definition of reversible process, we say like this: it is the process in which at every stage the driving force is infinitesimally greater than opposing force, and the process can be reversed by slight increase in opposing force. So that is called as reversible process. In the definition of reversible process, here 2 words are there. Which are 2 words? So that is driving force and opposing force. And another word, so that is infinitesimally. You see here, these 3 words are very important in the definition. Driving force, opposing force and infinitesimal. Infinitesimally change. Driving force means if any gas is enclosed in a cylinder which is fitted with wetless and frictionless piston which is movable one. Here driving force means the force which is acting from inside the gas on the piston. If that driving force is more, piston is pushed in upward direction. And opposing force means the force which is acting on piston from external side. If it is more, then the piston will be pushed in downward direction. So these are the driving force and opposing forces. But these two types of forces, they are infinitesimally differ from each other. What is the meaning of word infinitesimally? Means it's very small difference is there. So that is called as infinitesimally differ from each other. If suppose, we'll consider example, someone student got 90% marks in annual examination and other student got 89.99% marks in annual examination. 89.99 and 90%, they are approximately same, but they are not exactly equal. They are approximately equal, means that difference is called as infinitesimal small difference. So in this manner, in driving force and opposing force, if there is infinitesimal difference, infinitesimal change, then the process can be reversed. We'll see here actually to explain this reversible process. Gas is filled in the cylinder which is fitted with wetless and frictionless movable piston. Suppose P is the pressure of the gas and PEX is the external pressure applied on the piston. Both the pressures are equal to each other or same. Then what will happen? This piston will not move either in downward or in upward direction. Its position will be fixed. It will not move in either direction. So this is called as mechanical equilibrium stage. The stage at which internal pressure of the gas and external pressure which is applied on the piston, when these two pressures are same, then this piston is immovable, and so this is called as the mechanical equilibrium stage. If we change externally the pressure on the piston by infinitesimally small amount, suppose it is by P minus dP, then what will happen here? Due to the infinitesimally small change in external pressure P by amount dP, the piston will be pushed in upward direction. Why? The volume of the gas will increase. Here, volume of the gas will increase and piston will be pushed in upward direction, and it will be stable at a certain level, and it attains the another mechanical equilibrium stage. If we consider the case in which the external pressure on the piston which is increased by a small amount dP, then what will happen here? After application of the pressure from external side on the piston by infinitely small amount than the internal pressure of the gas, then the piston will be pushed in downward direction and its volume of the gas will decrease. At somewhere this piston will be get stable and immovable. At that time, internal pressure and external pressure on the piston will be equal, and that stage is called as a mechanical equilibrium stage. So in this manner, in the mechanical equilibrium stage, slight change in the driving and opposing force, the process will get reverse, and in this manner that process is called as a reversible process. What are the features of reversible process? Features of reversible process. Features reversible process. There are 4 to 5 features which are considered regarding the reversible process. First feature is that here driving force and opposing force, they are slightly differ from each other. First feature, driving force and opposing force is slightly differ, or we can say is infinitesimally differ from each other. Infinitesimally differ from each other. Differ from each other. Second feature is that the process can be reversed at any stage by slight increasing opposing force. You see here, the process can be reversed. Process can be reversed by slight change in opposing force. Third feature is that this reversible process takes place very slow and in infinite number of steps. That is the third feature. It takes place very slow. It takes place very slow and in infinite number of steps. Infinite number of steps. Fourth feature, we can write at the end of every step the system is in equilibrium with the surrounding. You see here in fourth, we can say that fourth feature, at the end of every step, at the end of every step, the system is mechanical equilibrium with its surroundings. Mechanical equilibrium. Mechanical equilibrium with its surroundings. With its surrounding. And last, fifth feature is that maximum work can be obtained in this reversible process. Maximum work is obtained. Maximum work is obtained in this process. So these are the 5 important features of the reversible process. We'll say again one by one. In reversible process, we know that 2 types of forces are acting. One is driving force and another is opposing force. And in this process, these 2 types of forces are infinitesimally differ from each other. So that is the first feature. In second feature, at every stage or at any stage, the process can be reversed. How? By slight increasing opposing force. In third feature, this reversible process takes place very slowly and in infinite number of steps. You see it. Already this process is very slow, and then it takes place in infinite number of steps. We don't know how many steps are to be taken place in this reversible process. It takes place in infinite number of steps, and due to that infinite number of steps, the fifth feature is there: maximum work is obtained in this process. We know that in each and every step certain work is obtained. We will see what is meant by work in next point. In each and every step certain work is obtained, and in infinite number of steps we take the addition of all these works which are obtained in every step. That work obtained is a maximum work. In fourth feature, so that is important one, at the end of every step of the system, it is mechanical equilibrium with its surrounding. At the end of every step, the system is in mechanical equilibrium with its surroundings. You see here. At the end of every step, we know that if gas is filled in the cylinder, which is fitted with external pressure applied on it, on the piston which is movable, then internal pressure of the gas and external pressure of which is applied on the piston, when these two pressures are same, that piston will be stable at certain stage. It is immovable. So at that time it is called as a mechanical equilibrium. And such type of mechanical equilibrium which is present in system and surrounding at the end of every step. So this is the fourth feature, and fifth feature, maximum work is obtained in this process. So these are the certain important features of the reversible process. Question in board may ask like this: define the term process and that on the features of reversible process, or define reversible process and write down the features of reversible process, or simply the question on features of reversible process may ask, write down the features of a reversible process. Then next point which we have to consider, that is nature of work and heat. Nature of work and heat. Nature of work and heat. So first of all, we'll see what is the nature of work. Nature of work. And then we'll consider the nature of heat. Before considering this point, we should know that the energy of the system can be exchanged with surrounding by two ways. Which are those two ways? In the form of work and in the form of heat. Any system, it can exchange its energy with its surrounding in two forms, in the form of work as well as in the form of heat. We will see how it happens in case of nature of work. Here we will define what is the meaning of work. How we can define work? Work, according to the definition of mechanics, we can define as, work can be defined as the energy due to which the body can be displaced through a distance d with the application of force. So that is called as work. You see in this definition what is given. Work can be defined as the energy by which a system or a body can be displaced through a certain distance d with the application of a certain force. So that is called as work. Means here work can be defined as W is equal to force into displacement d. But in thermodynamics, here nature of work which we have to consider, so that is the PV type of work. or we can say pressure volume type of work. In thermodynamics, work is pressure volume type of work. Pressure volume type of work means what? The work which is done due to the compression and expansion of the gas when internal pressure of the gas is P and there is certain pressure from external side on the piston. At that time, what the work is done due to compression or expansion, so that work is called as pressure volume type of work. Means here pressure, that particular gas exerts a pressure P and it has a certain volume V, but this work is done against a certain external pressure. That work is called as pressure volume type of work. Here PV work is equal to, suppose above equation is equation number 1. How we can define pressure? We know that pressure is equal to force upon area, or we can say force per unit area. Here instead of pressure we can put here force upon area into volume V. So this is equation 2. But here what is area and what is volume? Area is the area of that particular piston, and this area is nothing but the distance square. And what is the volume? V. Volume V is the distance cube. Here by putting the values of A and V in this above equation 2, we get PV is equal to F divided by A means distance square and this volume means distance cube. Here again PV is equal to F divided by D square. This distance cube can be written as distance square into D. Means here this distance square gets cancelled and PV is equal to this force into this D. So that is equal to W. Suppose this is equation 3. You see here, according to this equation, W is equal to F into D. Here also F into D is equal to W. So therefore the work done in thermodynamics, so that is a PV type of work done, and this work done can be explained by considering following 2 examples with the help of chemical reactions. How chemical reactions? The reaction of decomposition. You see here, decomposition reaction we have to consider. Here we have to consider the decomposition of H2O2. H2O2, so that is liquid which is filled in this cylinder fitted with the piston, and when it gets decomposed to H2O2 liquid and gets decomposed, formation of 2H2O liquid plus O2 gas takes place. When decomposition takes place, when reactants are decomposed and formation of product takes place, here in addition to 2 molecules of water, here oxygen gas is also produced. Here we have to put on the piston, so that is certain mass. From external side there should be a certain mass. Here what will happen here? Due to production of O2 gas, you see here, initial position of the piston was like this, and due to the production of O2 gas, this piston is pushed in upward direction. Means the mass which is kept on the piston is lifted in the surrounding in upward direction. Means this expansion of O2 gas. So that is here piston is pushed, means the mass which is kept on the piston is pushed in upward direction. You see this mass is lifted here in decomposition of H2O2 liquid. We'll consider another case in which same consideration. Piston is fitted, mass is kept on the piston, but here reaction which we have to consider, so that reaction is NH3 gas plus HCl gas gives NH4Cl solid. NH4Cl solid. Here HCl gas when reacts with NH3 gas, when these two gases reacts with each other, there is a consumption of gaseous molecules and then get converted into NH4Cl solid. Here what will happen? Due to consumption of gaseous molecules, its volume will decrease and this piston will come down, and this mass which is kept on the piston will be come down. It is shown in this figure like this. Here piston will be come down. So this is NH4Cl solid. Means here, so it is expansion and it is contraction. Means here, in this manner, while considering the nature of work in first reaction or in first example, in the decomposition of H2O2 liquid, it gives H2O liquid and O2 gas. Here O2 gas is produced, and due to the production of O2 gas, this piston is pushed in upward direction, means the mass which is kept on the piston, it is lifted in the surrounding. And in another example, NH3 gas plus HCl gas gives NH4Cl solid. Here NH3 gas and HCl gas are filled in the cylinder fitted with piston on which certain mass is kept. Here two gaseous molecules, or we can say 2 moles of gases, 1 mole of HCl and 1 mole of ammonia, formation of 1 mole of ammonium chloride solid takes place. Means here in the reaction HCl and NH3 gases are consumed and they gets converted into solid ammonium chloride. So due to that, the piston will be pushed in downward direction, and eventually the mass which is kept on the piston, it will also come down. So in this way work is done here. While lifting the mass, energy is lost by the system to the surrounding, and it is equal to work by system on the surrounding. And while this mass is come down, then it is energy is lost by the surrounding and gained by the system, and it is equal to work done by the surrounding on system. Then we will see the nature of heat. What is the nature of heat? We know that when system and surrounding, when they are kept at different temperatures, so then there is exchange of heat between system and surrounding takes place. For that purpose also we can consider one example. We have to consider here water bath. Here water bath is considered, and in this water bath the beaker is immersed in which a chemical reaction is taking place. So this is the water bath. So which is kept at room temperature, and here thermometer is also immersed to measure the change in temperature. So this is thermometer. You see here, in this beaker which is immersed in this water bath, so there is HCl and NaOH. When HCl and NaOH are added in this beaker, the neutralization reaction takes place, and during the neutralization reaction, you see here HCl plus NaOH gives NaCl plus H2O, and this during this neutralization reaction the heat is given out because it is an exothermic reaction. Here in this exothermic reaction the heat is given out, and this heat you hold during this system, it is exchanged with the surrounding, and then the temperature of the water bath is increased, which is noted on thermometer. In another case, instead of this HCl and NaOH, if I am not drawn the figure, instead of this HCl and NaOH, if we have taken the ice in this beaker, ice, you know that temperature of ice is 0 degrees, and this temperature of water bath is at room temperature, suppose. When ice melts, at that time it is an endothermic process, means heat is taken in, and that heat is taken by the surrounding itself, means from this water bath. So due to that the temperature of water bath decreases. So in this manner we can explain the nature of heat. Then we have to see the sign conventions of work and heat. Sign conventions. Sign convention of work and heat. What are the sign conventions of work and heat? We know that work W, it may be positive, it may be negative. Then heat, it is notation is Q, it may be positive, it may be negative. What is the meaning of W positive, W negative, Q positive, Q negative? So these are the sign conventions. When work is positive, when work is done on the system by the surrounding, then that work is called as positive work. Work done on the system, by the surrounding. So that is called as positive work. And what is negative work? Work is done by the system on the surrounding. You see here work is done on the system means work of compression, and work is done by the system on the surrounding means work of expansion. Work done by the system on the surrounding, which is expansion work shown by negative sign. What is Q positive? When heat is supplied to the system, that supplied heat to the system is heat, system gains heat from the surrounding, so that is always positive, and its internal energy increases. You see here, heat gained by the system, from surrounding. So that is called as Q positive, positive heat. Negative heat means heat is evolved by the system to the surrounding. by the system to the surrounding. Or we can also say that heat is given by the system to the surrounding. So in this manner, so the sign conventions of work and heat we have completed. Let us have to solve one neat question which depends upon previous video. You try to solve your at home and send its answer in comment box. We will discuss its answer in next video. Thank you very much.